Um, Hi everyone. Thank you for joining us today for today's session. Welcome to our virtual open week session. So I'm with Hossein, who will be presenting the insights in electrical engineering and renewable energy here at EIT. So just before I hand things over, I just want to share a couple of tips. If you can just ensure that all your notifications and sounds are disabled, so you don't get any form of disturbance when you're trying to listen or watch the session. So if you can just follow the instructions I showed, I displayed on the channel. So if you can just ensure that you take off those notifications. So this is day 2 of our virtual open week. So obviously we've created this platform for our students, potential students who are looking forward to sort of like going into the engineering space, and they sort of like want to know more about EIT, our courses, to know more about our lecturers. So we sort of like created this virtual open week platform so you can get to know more about our courses and our lecturers. So just some of the common questions that we get. So we will be sharing the recording together with the slides of this session. So just ensure that you check out your emails. We're aiming to send this out by Monday, 21st of October. So like I mentioned, sometimes it doesn't go directly into the inbox. So have a look at your junk or spam folder. I will now then hand things over to Dr. Hussein. Thanks very much.
Thank you very much, Barry. Thanks everyone for joining this session. I'm just taking the control if I am able. Yeah, apparently yes. Um, okay, so I'm Hossein. Currently, I'm working at EIT as a senior lecturer, and I have been working before in industry in a company called Magellan Power, and in which we are designing large scale energy storage systems. I have done my PhD in Singapore in 2018, and I have been also working in some other research institutes as well. So today I will be sharing some of the insights in electrical engineering, some of the work opportunities, and mainly what we as EIT offer in electrical engineering. Just Okay, so the contents for today, we will be talking about the electrical engineering and renewable energy. What is electrical engineering, and what is renewable energy? What are the trends that we have in electrical engineering? And later on, as I mentioned, we talk about potential job outcomes and courses that EIT offers in electrical engineering. So what is electrical engineering? So simply, if we look at everything around us, wherever you are sitting in a house or in an office, etc., you would see that everything around you is electrical equipment. Everything, almost 100% of equipments that you have in your house around you are using a type of electrical energy. So you can think of, let's say, air conditioning in your house or in your office, or the trains that we have, or even your laptop that you are looking at the moment. So there are different spectrums that we have in electrical engineering, right? So it could be on electronic sides, like electronic mobiles. It could be high power equipments like trains, etc., or it could be the motors or motor drives that they could range from very low powers to high power ranges. So on electrical engineering, we have many subfields in encompasses electronic, computer systems that we have, telecommunications, controls that have been used, and I will be discussing about few of them in this session. Electrical engineering is a way, it looks at the way that electrical energy is produced and it is used, and how efficient that energy is transferred from the point of uh, production or generation into the point of consumption, which is your house. On electrical engineering, we look at designing and building systems and machines that control an equipment, like for example, in a lift of your house or your building, we have an electrical motor which has a drive, so and it requires a control. So these are different aspects of electrical engineering that we have. Going a bit more deep on each of these fields, for example, we start at power plants or power generation systems in which they have these high power synchronous generators or generators. For example, hydropower plants we can do, or the then at the same time we can look at the power plants that are based on renewable resources like wind power plants, etc. So they are the sources of energy. So in electrical engineering, we will look at the basic and principles on how this electricity is being generated in each of these power plants, what are the aspects of each of these power plants, etc. Then it comes to how do we distribute and transmit the power from the source of generation, either being conventional power plants or renewable resources, to the point of consumption, under which we study the principles and design of transmission line, transformers, the devices that we need to use to ensure the power system is stable under several conditions, etc. So these are different aspects. When it comes to the consumption and control of the loads, we look at how are the loads, for example, generates harmonics, and how do they behave to the power system, and how their operation impact the power system. On the other side, another aspect we would look at telecommunications, for example, the platforms for that we have, for example, 5G mobile communication, 4G mobile communication, etc. So the platforms that we look and we have to transmit what we call as data from one location to another location. It also looks at, of course, the lighting, etc. Another aspects of electrical engineering is electronics. Electronics, you can see the, for example, printed circuit boards that are in your laptop or in your monitor or in your microphone. So these are the electronic boards that, again, all of them are following the electrical principles, and one part of electrical engineering looks at the design of electronics. Of course, we have some applications in which they combine the operation on the usage of both electronics and, for example, power. For example, in one of the examples would be power electronic converters that we have around us. For example, if you have a PV or photovoltaic inverter or solar inverter in your house, that solar inverter, it has multiple stages and multiple components. Some of them are the components that deal with high voltage, high current in the system, and some part of that would be a controller that is based on electronics or microelectronics. In the same case, of electrical engineering, we also deal with embedded systems in which there are microelectronics which are normally used to control and program the operation of electrical engineering devices. So, as an in summary, as an electrical engineer, you would help to power the world, and you will work with other engineers to make all the things modern in the modern life, and you make them faster, smaller, and better for environment. So let's look at some of the uh, technology technological growth that we have had in the last few years, and let's look at some of those aspects in electrical engineering. From, for example, from this curve that you can see from 1,400 year for 1,400 till now, that which is 224, the growth of the technology has been exponentially increasing. Right at the beginning, for example, it was kind of very much smooth, not much of development over many years. But in the last, just in the last couple of years, if you guys think around yourself, the advancement that we have had, especially in, for example, electronics, devices, and the communication, has been tremendous. And this is where part of this technology advancement comes from, the electrical engineering. And for example, designing smaller chips, designing a smaller integrated chips with many transistors. How do we link these transistors? How do we manufacture these transistors? How do we control them? Is one of, again, one of the aspects that we study in, for example, digital electronics and manufacturing of semiconductors in electrical engineering. So all of this growth that we see around us, one of the main aspects of this growth is through electrical engineering. For example, as another example, if you look, is the smart grids or microgrids, that just in the last couple of years, from 2019 to 2024, we have had an increase in the what we call as in their integration and in the integration and their integration into the grid. Another aspect that we can look is, for example, the growing industry that we have in electrical cars, that you guys can see in the last couple of years, we have had again a tremendous increase in the installation and integration and selling of electric vehicles. So in electric vehicles, we have many technologies that they need to be working together to make these technologies a successful technology. One of the technologies is a battery, or which is an equipment in which is an equipment in electrical vehicles to store the energy so that we can the car can drive for long distances. So the battery technologies, for example, the advancement that we have had in the last few years, it's how to make them safer, how to increase their power density so that they have higher amounts of energy stored for longer distances, how to decrease their weight, etc. Another technology and another advancement that is required for the electric vehicles is autonomous vehicles, which is again integration of, for example, artificial intelligence in detection, and autonomous vehicles would be another advancement that we have in electrical cars. We have again a big increase in the charging stations, car interiors, and electric utility improvements that help to integrate the charging stations and large power stations into the grid. Another important aspect that we have in renewable energy, in electrical engineering, is renewable energy. Renewable energy, as a general definition, if I would like to mention, is to so that we have a clear understanding and definition of what we call as renewable energy, I can mention this sentence. Normally, we define energies or the energy resources that can be reproduced in the age of over an average age of a human. For example, if we look at solar energy that is being produced by sun and is being absorbed by the earth, this energy, whether we use it or not, is every day exported from, I mean, it's coming from the sun or irradiated from the sun towards the earth, right? So this energy is being reproduced every day. So another case would be, for example, wind energy that has the same structure. So these types of energies, their main their main feature is that they are or they can be reproduced in over the age of a human age. And recently, in the last few years, the integration of renewables has been increased in the power system. Of course, one of the reasons is, yeah, they are the sources of energy that are sustainable. The other reason could be the other reason is the reduction of the greenhouse effect or the greenhouse gases that are being emitted by the conventional power plants. So there are many reasons that we have, and we have a big interest recently in integration of more renewable resources into grid. But on the other side, we need to keep in mind that renewable energy resources, even though they are environmentally friendly, even though they are sustainable, and so on and so on, in addition to all the advantages they have, they make some big challenges to our system, to the power system. The main reason here is that the power system that is being at the moment has been installed and is being used for many years is not ready, is not yet fully ready for integration of these renewable resources. On the other side, this power system has been designed and installed many years ago without consideration of renewable resources. So now we are adding a new component into the power system or power grid in which is not ready for that integration. So this is making many challenges, and one of the one of the aspects that this is one of the aspects that we study, we research, and we develop in electrical engineering. And let's look at this sentence from Lynn Good. As when one thinks about the current energy world, it's easy to see that we are undergoing to a transformation of movement in a transition to a more renewables. That's clear for, I think, all of us, and that's something that we can every day see around us in residential houses, in EV cars, and the wind power plants that are being installed, and so on. And of course, we have the an increase of the installation of renewables. For example, this curve we can see the increase on the integration of distributed PVs or the larger scale photovoltaic power plants. How are they being increased? How their installation being increased, and so on. So this is again another evidence that we have for higher integration of renewable resources. So the future of electrical engineering, we look at faster and more efficient wireless charging systems for electric vehicles, for electronic devices like mobile, etc., which is another aspects of research, development, and manufacturing in electrical engineering. We talk about, or we work in the future, we work with more and more integration of renewable resources. One of the aspects that we also discuss and research is about higher energy efficiency in the system. Of course, everyone nowadays know we have the advancements in AI and artificial intelligence, in which can be used in robotics. It could be used in autonomous vehicles and a lot of different applications in electrical and renewable energy. And of course, to make faster electronic and smaller electronic devices and faster electronic devices, we need to have advancements in microelectronics and nanoelectronics for designing the chips and other aspects in this area. One of the important things that we have in this case is the case of sustainability, and this is one of the reasons that we have and we go towards more and more renewable energy, that to make the power system and energy resources that we have more and more sustainable for future. Coming to this point, we would like to see what we as Engineering Institute of Technology offer to prospective students in the area of electrical engineering. So we have many programs in this area. We start with vocational training unit courses that we have, for example, graduate certificate that we have in renewable energy technologies, which focuses on different aspects of renewable energy with a deep analysis of each of these technologies and their challenges for integration with the power system. Then we have, for example, Bachelor of Science degrees, which Bachelor of Science in Electrical Engineering or Electrical Systems, which starts and which mainly focuses on broad aspects of electrical engineering, like machines, power electronics, signal processing. There is some information, also some units about communication, big data analysis, etc. And this is another case that prospective students can learn a lot of aspects of electrical engineering. Then we have on a higher level, as well as and more deep analysis on electrical engineering. We have the course on Master of Engineering in Electrical Engineering. Sorry, Master of Electrical Engineering, and in this course we mainly focus on the power system protection as well as renewable. So here the main focus that we have in the Master of Electrical Engineering is a deeper analysis on the aspects of renewable energy integration in the power systems. Then on a higher qualification, we have Doctor of Engineering, that hopefully everyone is familiar, in which we are looking at innovative and the state-of-the-art technologies in advanced electrical engineering perspectives. For example, we have projects or DEng students working on the protection issues of microgrids with integration of renewables, and some of the issues that some of the projects or innovative projects that we have in this area. And on the units, for example, on the Master of Electrical Engineering, you can see the units that we offer is for the units we have on power generation, on transformation distribution. We have a unit specifically for renewable energy systems. We have a specific unit for power system stability, which again we discuss different aspects of stability with high penetration of renewable systems. We have a specific unit, a very specialized unit on smart grids, studying different aspects of smart grids, technologies that we have, etc. And we have a unit on power quality and substation design. Then on the other sides of the other programs that we have professional certificates, for example, in arc flash for battery design, and we have the professional certificate in big data analysis, and for example, in electrical power systems, etc. So they are the professional certificates that you can obtain, and you get a specialized knowledge and experience in some of these specific areas that uh, are of your interest. We have many softwares that we use in our units. All of our units from bachelor to the master, as well as the professional certificates and undergrad certificates, they are combined with practical assessments, questions, etc., that are helping the students to get the hands-on experience with software tools that are normally used in industry. So one of the big advantages that I would say we as EIT have compared to any other universities in the world is our main focus is uh, industry and applications of the knowledge in the industry. So that's why all of our courses, from the vet courses or vocational training courses to the Doctor of Engineering, all of our focus in all of this program is looking at the software tools, is looking at the experimental systems, is looking at the case studies that are uh, practical cases and used in industry. So as an example here, for example, on softwares, we use ETAP, PSCAD, Power Factory, that some of you might be familiar and is one of the most expensive software tools in electrical engineering, and most of the consultancy and power system operators in different countries use it. So, for example, we have access to the Power Factory, and we have integrated this in several units, and students do many projects on this specific software, for example. And there are some other software tools like Homer Pro that is being used for the design and economical analysis of renewable resources, and do different case studies in this area. Uh, Additionally, in all the bachelor as well as master courses, students need to attend hands-on workshops if they are not working and don't have the experience, industrial experience. In this intensive hands-on workshop experience, so in all of these workshops are helpful for students to get an experience with different equipments, like, for example, what we see in the middle is a programmable inverter, which is exactly a similar hardware that is used in most of photovoltaic inverters in houses. Or on the left hand side, we have a power transmission board in which we have a few contactors and motor drives and etc., which are exactly similar to the experimental or available applications that we have around us. So students really focus on this learning of hands-on, and they apply the knowledge that they gain through the units into a real world application. Potential job outcomes, we can look at the jobs like electrical and electronic system design, infrastructure, in oil and gas industry, in mining industry. We have a lot of works in electrical systems, and nowadays, especially that all of you may notice, we have all the companies that are going towards more electric devices, being either industry, for example, mining industry, which we had previously big trucks which were diesel, and nowadays going towards electric trucks in mining. And by going there, for example, we need going to that direction, we need big energy storage systems, big charging stations, etc., in minings. This is just an example. You can think of this in any other aspects. For example, in aerospace, we are looking every day towards all the companies looking for more electric aircrafts. And for example, companies like Rolls-Royce are looking for the design of the aircrafts with higher integration of electric systems rather than mechanical or pneumatic systems that existed before. So by having the degree in electrical engineering, you have an open door to many opportunities and career opportunities for future. One of the one of the important things that I would like to mention while you are reading for example, uh, the statements that we have from our graduates, one of the important things that we have in electric EIT is that our lecturers are also from industry. So again, this in opposition of universities that we normally have professors or lecturers that they have been always in university and focus on academia. Uh, and in those cases, mostly what they teach, etc., is mostly theoretical studies, not, and sometimes it's less practical. We in EIT, most 90% of our lecturers are casual lecturers that are already working in industry. They are pioneers and experts in specific fields in industry. This makes a big advantage for students because the students learn from the basics to the application of the theory from the experts in industry. And I would really emphasize always that this is a big difference that we as EIT have compared to the other universities, having industry-based lecturers. Some of the statements from our students that are always positive. For example, EIT has a different feel because it's a small community, so you are easy to access to management. Any difficulties or challenges, they are really there to help you with. Thank you very much, everyone, for listening to this presentation, and I'm happy to answer any questions that arises from this presentation or any other general questions about electrical engineering. Barry, is there any question that you want me to answer? Is there? Or you
Yes.
can read all the chats?
Yes. There's just I think I see there's a couple of questions. The first question was, what is the y-axis measure?
I guess that is related to one of these figures, most probably this one. So this is the index of advancement in the technology and how small and advanced are the technologies. So what we have in the y-axis is really the number of innovations per year, and this is what is increasing, and this is what is being increased in the last few years exponentially. For example, and the number of innovations and products that we have in the case of IT, in the case of renewable resources, etc. That's what this curve shows on the y-axis. But the main summary of this curve is see really that the advancements in technology are getting higher speed nowadays, and one of the areas that we can work on and we can study and research is electrical engineering, which is helping this big advancement.
Um, Thanks. And the second option, just one wanted to know how intense is our master's, our bachelor's.
I guess what I understand, I think we have part-time bachelor students, right? But I guess this is the information that you know very better than me.
So what I'll do is I'll just share more information with the person, and then the hydrogen technology and climate change, are the course or units integrated in renewable energy courses?
So if you are interested to study hydrogen, there is a specific program on vocational training for hydrogen and hydrogen integration. Barry can give the exact name of that program. If you are really interested in studying hydrogen and hydrogen technology. Additionally, in the electrical system units on renewable resources or renewable units, we have some aspects of hydrogen, but we are really looking at the application of hydrogen, like fuel cells, electrolyzer, etc., for higher integration of renewables. So the answer, I guess, is yes and no. We have some aspects of that in electrical systems, but that's a bit of just looking at the application, not at the details technology.
I guess there's one who wanted to know about the software programs we use. I guess you shared that earlier on, so we will be sending the slides and the recording of this session to your email, so you can get that information.
Yeah. So again, to a quick answer to this question, we on the master as well as bachelor of electrical engineering, we have software tools like Power Factory, PSCAD, PSSE, Homer Pro, AutoCAD, and of course MATLAB Simulink and MATLAB Simulink. These are the main softwares that normally we have, unless there is a specific software that you are looking for, and you can ask Barry whether we check whether we have it in our units, etc., or not. The other question, is there any coding or programming in electrical engineering course? Again, the answer is yes. On the Bachelor of Electrical Engineering, we have a specific unit. We have a specific unit for programming, in which we teach Python programming as well as the C++ and some other programs. Is a brief, each of them. But on the application of the software, we have many assessments in different units, including the master units, that they need programming. For example, one of the units that we have in workshop is programming even a microcontroller, programming of the Arduino controllers. These are the embedded system applications, or we use Python programming in some of the units for big data analysis, etc. Hopefully that answers your question. Is the master's degree recognized by Engineers Australia? My understanding is yes, but Barry, I guess you are the best person to answer this question.
Yeah, so we have currently have 3 of our masters, which is industrial automation, electrical, and we have civil. I will share that information just now.
In the meantime, I answer the next question, which is, can the master's degree be structured for specific areas of interest, or is it a general course? The course is Master of Electrical Engineering is a designed specific course which specific learning outcomes. So the answer to this question is no. We don't have a specific program for specific individuals. The program is a general program that includes specific areas of electrical engineering. It's not specific to a person. However, saying that, in the master's degree, we have one semester out of 4 semesters, which is for master thesis. In that thesis, the project and thesis can be defined by the student in the area of the interest for student. And this is where we as supervisors normally always encourage students to work on or to define the projects for master thesis in area of their interest and the area that they normally work at. So I guess that's the answer for this question. How many years of professional experience is required to enroll for the Eng? You can look at the exact requirements for the Eng. What I know of, and Barry can correct me, is the Eng we are looking for having a bachelor's degree or master's degree. That's the main criteria. But as part of the enrollment for the Eng program, you need to provide a research proposal, and there will be an interview with few academics in which you will be presenting your research proposal, and you need to have either from your master degree or from other experiences, you need to have some background in research to be successful in that interview or in that research proposal interview. I guess that's answered. Softwares which is used in your institute. I guess I mentioned some of the softwares. Power Factory, PSSC, PSCAT, Homer Pro. And thank you. So again, for artificial intelligence, we have a vocational training course on artificial intelligence. Again, Barry can send you the details. But we also have industrial automation, which is a bachelor of industrial automation as well as master of industrial automation. And part of this industrial automation works around the artificial intelligence and its application. So I hope that answers. In electrical engineering, again, to have a clear answer, in the electrical engineering, we use AI, but not we don't have specific units on AI, but we have in many units we have assessments and projects that are requiring AI in electrical. Yes, requiring AI or applying AI for electrical engineering. The next question: Do you accept a national diploma for masters? I guess Barry, you are the first person, or whoever, Lee.
So for a master's program, you need to have at least 3 or 4 year bachelor's degree in engineering.
Yeah, okay. I guess that answered your question. And what course would be suited to me, being that I have zero knowledge of engineering? So I guess the next question: I am a lawyer from Kenya. What course would it be suited that I have zero knowledge of engineering? Barry, any idea?
Yeah, so since most of programs, they need some sort of a background in the engineering space or relevant qualification. So I'll suggest that you look look into our professional certificates. So I will provide you more information so you can view more of our professional certificates. Thanks.
Yeah. Thank you very much. And I guess the next question: Do you accept a national diploma for masters? I guess that was a no, if I'm not wrong. And the next question we have here, I am interested in power system and energy generation. Please, can I get a fully funded scholarship to study at EIT? Though I'm currently at second year in my BEng in Nigeria. Regarding the scholarships for master, again, I am not fully aware. Barry can help, or Lee?
Yeah. So unfortunately, we do not have fully funded scholarships. All our scholarships are partial. So I also just shared the information so you can read more about our scholarships and bursaries.
Thank you very much. I am an electrical engineer with over 8 years of professional experience. Do you accept 2.52 CGPA for masters? I guess my understanding is that we are looking at the criteria on the case by case. There is a minimum requirement, but due to your professional experience, your case could be accepted. So most of the time, this comes on a case by case and overall profile of the applicant. And I think that's all. Do we have any other question that we missed?
I think that's it for today. Just want to thank you, Dr. Hussein, also my colleague Leah, the rest of the audience for joining us today. I don't know if there's a last comment that you want to share, Dr. Hussein.
No, yeah, thank you very much. Nothing specific from my side. Hope this session was helpful, everyone, to get some insight on electrical engineering, the job opportunities that we have, and the areas that we work in electrical engineering. And hopefully, you get some interest on some of the programs that we offer in this area. And hope to see you guys soon in one of our units. Thanks everyone for attending.
All right. Thanks everyone. Till we see each other in the next session, which is tomorrow. So if you are still interested in joining our open week, so I will be sharing the link in the chat box so you can register for the other sessions. Thanks once again.
Thank you very much. Thanks.